Hi, welcome to Mix and Jam, a channel about game development experimentation. Today's project is based on God of War for the PlayStation 4. In the newest game of the series, Kratos has the ability to throw his axe and pull it back, making for a mechanic that feels and looks great. My goal for this project is to try and create a similar mechanic using Unity. Here are the steps I needed to follow. First, I needed to add animations for all of the character motions. Then, I needed to work on the axe throw itself, in which the axe is detached from the player and moves forward while rotating. The axe collision, that makes it stick to the walls. And the axe return, where the axe returns to its original position with a small curve. For this project, I created a third-person character control following this video from Filmstorm that teaches how to create that kind of camera control using Cinemachine. I also downloaded this model of Kratos' axe from Dan Hardo in Sketchfab. And like the last video, I downloaded some animations on Mixamo to use on the project. I started by applying the downloaded animations into the character animator. On Unity's animator, we can organize the character motions, create transitions between them, and set parameters that we can modify by using code. In my case, I used code to set the walking parameter on whenever the character moves so the animator could transition to the proper animation. By using the same technique, I was able to set the aiming and throwing animation. For the axe throw, the first thing I did was to add a rigid body component to the axe. To avoid it from being affected by gravity, I've set the isKinematic property on. In code, all I needed to do for the throw to work was to detach the axe from the player by setting its parent to null, setting the isKinematic property off, and adding a force to the rigid body. By throwing the axe and playing the animation at the same time, the axe is thrown way before the animation reaches the proper frame. To fix that, I went into the throw animation and created an animation event exactly at the frame I wanted the throw to happen. On the animation event, I simply call the throw function on my script. In the game, the axe rotates while moving forward, so I replicated that by creating a script on the axe that changes its Euler angles on update. On that same script, I added Unity's onCollisionEnter function to detect whenever the axe collides. So in that function, I just made the axe freeze by setting isKinematic on the rigid body to true. To make the axe return, I used some of the techniques I found in this video from Omar, in which he also recreates the same axe throw using Unity. This video really helped me a lot, so shout out to him. In his video, he uses lerp to make the axe return, and he also uses a quadratic Bezier curve to make the axe do an arc when returning. I did the same thing and placed an empty object as a child of the character to use it as a middle curve point. For when the axe is returning, I added a pull animation for the character. Now for some polish, I added some basic particle effects to the axe. One for the glow of the axe that uses the mesh as a shape for its emission. And another for when the axe is catched with a single emission of a bunch of particles. I also added a trail renderer to the axe as well. To improve in animation a bit more, I did an extra animation state for when the axe is catched to make the motion have more impact. To add even more a sense of impact on the catch, I added a screen shake to the camera by using Cinemachine's impact extension and called it in code. I refined the particles and trail by changing their material. And just for experimentation, I added some breakable boxes I did on the scene so the axe could break them. And then finally, I added some post-processing to add some effects to the camera like bloom, depth of field, and motion blur. After some minor adjustments, this is how it turned out. As always, the link for the project's repository is on the description below. If you have anything you would like to see being made on a video, let me know in the comments. If you enjoyed this video, don't forget to like it, share it.
All right. Wow, it's pretty dark in here. I guess I'll be a little dark. Hope that was you guys enjoyed that. I know this channel does some fantastic stuff. This guy pretty much deconstructs lots of things you see in popular games and just recreates them in Unity real quick. And it's really interesting to see how he does it. You know, he's kind of just quickly prototyping some things. And part of what drew me to showing this to you guys is the fact that it is including a bunch of different animation techniques, as well as the fact that he's utilizing a resource such as Mixamo. And if we have time today, I will go onto the Mixamo webpage and look into just pretty much kind of configuring a character and animations, and then just bring them into Unity directly from there. It's kind of a nice online database of sorts where we can just kind of you know, pick what we want very, very easily, incorporate it into our applications. Okay, so let me get that blinking off of there. Let's go to some of the other things I wanted to talk about before we get into Unity. So I'll touch on this a little bit, but this is something you're likely to run into whenever you're bringing content from outside of Unity into Unity. You know, oftentimes it doesn't really come in the way you want. It's too big, it's too small, you know, the material, the textures aren't applied, or whatever it is. And the first place for you to look when stuff like that happens is to go and actually make sure that you have your assets selected. And this is actually outdated. You used to have to, in this example, this is an animation, right? And inside of the animation, there would be nested the thing that's actually the animation. And previously, you had to actually click that to see the properties. In current Unity, it'll redirect you to the root, which makes more sense. Anyway, when you have anything in the project and you want to kind of see what's happening in the conversion from outside to inside, you can kind of look at what we have to play with here. And one of the main ones you look at is often the scale factor, right? Things get modeled different scales, whether you're in Blender or they come in, you know, you pulled it off the web somewhere. In here, it can let you adjust that stuff. So by default, hopefully, whatever the file says it is works out well. If not, you can uncheck this box and change the scale. Read write, unless you're changing the vertices at runtime, it's probably better to keep that checked off. This pretty much just keeps a copy of your asset in memory. You shouldn't have to worry about it. Optimize, yeah, that sounds good. A blend shape is kind of a new concept we haven't really talked about yet, and we're not really going to go into much. The idea is that you could think of animations for characters, you know, they can be animated in different ways than just the skeletal animations that we've seen so far. You know, having bones and just transforming the bones and having the vertices follow is a great method, right? It really works well for a lot of use cases, but there is kind of another way to do it, right? If we just think, well, let's pretend I don't know anything about bones and I just want to animate some vertices. Well, you know, okay, I can just say, well, this vert is here on this keyframe. This vert should be at this other place on another keyframe, right? And so if you did this for a character, it's almost like you're specifying a whole new character for every keyframe, you know, and then now you could just blend between the vertices that make up a character in one pose versus another pose, and that would generate your animation. But as you can imagine, you end up with just a ton of vertices for that sort of thing. So this worked out okay back in the old days of, geez, the Quake games. Quake 3 was used this type of vertex animation, and really I'd say in the early 2000s is when things started shifting more over to skeletal. But this bit of history isn't really just to say that this is an old technique that's not as good per se, because there actually are very good modern use case where you might want to do this. And one of those might be for facial expressions. You might have a bunch of different faces, right? And you just want to blend those vertices. You don't want to set up bones for everything inside of the face, right? And really get in on that level. So, and when you want to have like really precise control over the vertices, that's kind of a good approach. So that's the idea there. So if you made multiple meshes like this might say, hey, bring that in. It can make colliders for you. If you had quads instead of triangles, it can do some things to preserve that. It doesn't really matter too much. Welding vertices, it's just like ProBuilder. We talked, Professor Darkin talked about before. If you have vertices in the same spot, it'll collapse those. Swap UVs. Oh yeah, so I guess if you have a texture that's somehow like rotated 90 degrees, then swapping the U and the V would maybe help that. Here's a checkbox that's definitely worth knowing, and let me see. Nope, I don't have that on. All right, and that's if you do baked lighting, which hopefully we'll have time to talk about at some point. But if you can remember from last quarter, the idea is that most ray tracing techniques without very impressive hardware is just not capable of doing computing very realistic light in real time. So instead, we can just compute that offline and store it. But the only problem is that anything that moves, it doesn't work for, because we pre-computed it. Basically, everything at runtime needs to match the way we generated the light information offline. But Unity system can be a little bit tricky when it comes to this, and a lot of headaches can be solved by like checking that box right there. You generally need a different set of texture coordinates to map lighting information than you do just for the diffuse albedo. Normals and tangents. So as part of your mesh data, right, vertices aren't just position, they have normals and lots of other stuff. And you can have Unity calculate that or not. And the idea of tangents is just that this is used for normal mapping, where if you have a, on your surface, right, we with just the basic Phong shading we did before, our normals were defined per vertex, but our lighting was calculated per pixel. So if we wanted our normals to also be per pixel, right, we could basically put a texture on top of the surface, and now the color of that texture represents the normal. And tangents is all about, tangent space is basically the space that's local and flat to the polygon, and that just helps you get per pixel normals to do normal mapping. And then there's some other stuff for import right there. But yeah, if any of this is a problem, come in here and play with it as you see fit. Let's come back to animations. So in Unity, you often see animations. They look like pretty much a separate mesh for the most part, but you can treat them as if they were just a separate animation thing. And the thing that we kind of worked on before, but I didn't really talk about the details too much, was the idea of blending between different animations, right? We saw that we have going from an idle to a walk to a run, right? And then there was very smooth transition between those things. But it's good to be aware of what it's actually doing, right? If we look at a single animation, we're just we're blending the bones, right? We have the bones at every keyframe, and then right, that's a single animation. So that has a pair of keyframes. Now, if you go between two animations, if you look at between maybe walk to run, now you know, there's keyframes for where you're at in the walk cycle, and there's keyframes for where you're at in the run. And now you have an interpolation that happens between those. So it's kind of like it's another place where you're combining these interpolations, and this sort of thing happens a lot in game development. I mean, Bezier curves are kind of based on that. If you remember, the Bezier curve is just created through a series of linear interpolations, and this isn't necessarily linear, but it's achieving similar kinds of things and making it smooth. Let's see, do I want to look at, for the web, there's a library called 3JS that originally did not have this feature, and I actually had the opportunity to add it in there myself. And if you look at this character, you can see that, let's slow this down a little bit. I can slow this time down a little. He's currently in his idle pose. If I click from idle to walk, we can see the weights of each animation as he gradually kind of blends from one to the other. Right now he's 100% walk. So if we go from walk to run, now see the walk is decreasing while the run is increasing, and that works out just fine. So, all right. I want to give you a little bit of a extra about finite state machines as well, because I guess here there be dragons, right? Like these things seem really nice for a lot of things because they're so simple and easy to follow, but then maybe what I just said isn't that true. Let's start right here. Here's a very simple finite state machine, and this is super easy to understand. It's communicates everything well. Yeah, you put a coin, it unlocks it, great, and then we come back here and you push and it locks it. Okay, I see what those states are doing. That's easy to read. And if I look at something in Unity, that doesn't look too bad either. But a much more realistic use case, you start to get stuff that looks like this. And I wouldn't really call this simple any longer, but this is certainly a much more realistic example of what you'd find in, I don't know, more of an indie game, something that's not necessarily AAA, but you can see, okay, we got stand and crawl. You can crawl around, slide and crawl, run and jump, fall, right? There's a lot of stuff here. So our character is actually capable of doing quite a few things. And if we take the time, I think it's not too daunting that you could imagine being able to figure out what's going on here. Let me check the chat. Let's see. So question is, for the final project, of a preferred method for citing any references, tutorials that we used. I haven't really thought about that, so I will definitely get back to you and let you know. This looks like one of Joe's FSMs. Well, okay, that's not too bad, but here's what can easily happen when you're dealing with state machines, right? Is once you get to this point, I don't know if this works, but it probably breaks under certain conditions, and I wouldn't want to be the person who comes in here and has to debug this. Finite state machines end up not being good for this kind of combinatorial explosion that happens like this. And there are methods you can use to organize this better, which would prevent some of this stuff. But I think, you know, once you scale from something that's small to something that's large, this might not necessarily be the right tool for the job. Although when it comes to animation right now, right, that's the tool we're given. So you can make this work. I'm just kind of thinking about using a finite state machine for like AI behavior, for instance, rather than just animation. You know, you can imagine stuff getting very tangled and messy just like that. So here's kind of one thing that helps organize things a little bit more. And we saw this already, right? It's the idea of a blend tree, although what we saw before didn't really look much like a tree, right? We just had idle, walk, run. It was kind of like a blend list for the most part. But you can really compose these things. So the first thing, or a child underneath this blend tree could itself be another blend tree, right? And that's kind of what makes it a real tree. So here's idle. There's not really any variation here, but okay, moving up. Well, move up can be different based on whatever this state is, right? Normal, medium, hard. And you know, you're just kind of coming in here and picking the right animation for your job. And you can see this one's based off of a speed X, Y, and a state. So there's definitely more complicated things you can do with these things than what we're really going to focus on in here. Back to what we were doing. All right, we just have this ready, walk, and run, and that's pretty simple. That gets us something we can play with. The omission that we're going to talk about today is making sure that our animations actually match our movement in the world. When we have our soldier just walking or running, his legs are moving around, but there's nothing really about that animation that is directly tied to his foot actually being on the ground. It's really just a matter of how fast, how we tune it to make sure that that animation looks like he's making contact and making firm contact with the ground and not slipping. So I want to get into this. I'll probably come back to this idea. I guess one of the things I wanted to mention when it comes to taming a finite state machine is the idea that I came across in this this talk right here from the Unity conference. It's called Unite. It's kind of like a game developer conference, but specifically for Unity. And this guy's talk was called Mechanim Bonsai. And Mechanim is the Unity animation system. And, Bonsai is kind of, that makes sense. It's like careful pruning and creation, which is probably the right approach you want to take when you're dealing with something that can become a real mess, right? And one of the patterns, as an example, that he came up with to do with this is called the hub and spokes. So I can maybe blow this up a little bit. It's the idea is that instead of kind of having everything go to everywhere else, you kind of have nodes that are kind of like hub nodes, right? Where they can kind of go out and come back in. And that's just kind of one of the patterns you could approach this. For like the full spiel on this, I can put these slides up, and you can check this link out if you are planning on doing a lot of animation. That might be worth a watch for you. So let's get back to Unity and let me remember what I had planned to do here. All right. So first things first, we want to make sure that our animation is synchronized as best as we can with our movement. To that end, I created a couple of custom scenes here. Got calling Catwalk, and this is basically just a very long strip where I have a character at one end and he's pretty much just running to the other end. And let's not use this. Let me remove that. What I'd like to do is I just want to watch this character as he runs, and then I can kind of just tune this to look, something that looks plausible. So to do this, I'm going to just take the camera and make the camera a child of the Navy SEAL, but I don't want the camera out there. I want it more where the character is at. So now I'm moving the camera relative to the SEAL. I can pull this out a little bit. Let's rotate like that. Let's bring it up a little bit. I really just want to look at his feet, so that might be okay right there. Now, as he runs, I should see in the game view. Well, I guess if he's not running, let's see what I have here. Let's make sure that I have check the console. So I think I have the nav mesh. Oh, you know what? I think I had a little thing in there that told him where to go. So follow target. Let's bring up bring up this script again. Okay, so I have this just little hack of a script here that allows me to just set a path, and if I have this Boolean checkbox set to true, it's just gonna continually be setting the destination to go where I want it to go. So nothing special there. That'll set the destination, and as before, we had the animator. We're updating that speed based on the agent velocity. So let's say yes, do auto path. Where is he at? So negative 490. All right, I'm going to, oh shoot, what did it, you know what, I put this on the camera. I meant to put this on the soldier. So let's drag it up here. And today this works, so that's good. I just grabbed this from the header, put it on the new object right here, and let's tell you to go to positive 490, and I think that'll do it. So let's see. All right. So he's moving, but he's moving kind of fast, and so it's a little bit hard to tell. So the next thing I would want to do to inspect this is actually slow things down a little bit. So to do that, we can go to Edit, go to Project Settings. I'm going to dock this here to the right. And there actually is a time field right here where I can change some settings, but the one I really care about is just scaling it. You know, right now, 1 second takes 1 second. So I'd like 1 second of simulation time to maybe take 10 seconds. So I can hit that to 0.1. And now we've got a little bit better of a look here. So what do we got? Actually, that looks okay for what he's doing right now. When he's at a full run, that seems like it's not too bad, right? His foot plants right there on the white, stays there. It doesn't move around too much, so it's not terrible. Let's look at some different speeds. Let's say he's just walking slowly. So if I change the nav mesh agent speed, he should slow down a bit, and an animation system is doing some funny things. I feel like there's some bugs in Unity when you're scaling the time and animation, but for our purposes here, I mean, you can see that he's very clearly kind of more running in place. So things are not synced up very well right here. If we look into our animator, let's go into the locomotion. It could be just, looks like it's freaking out because the value for the agent velocity is jumping around so much. So maybe it's not the animation, it's the animator, right? You can see the speed just going crazy back and forth. That's okay. Let's select our blend tree and see what we can do here. Currently we have it set to run anytime speed is greater than 1, which is definitely not what we want, right? We want speed to be closer to whatever his running speed actually is, which I think happens to be around 4.6. But you know, this threshold for walking, when you should be completely walking, should be when the speed exactly matches the walking speed, right? When we have a speed of 0, it should be completely all in the ready animation, and between not moving at all and moving at the walking speed should be the threshold to walk. And I don't know what that is, but let's try 1.5. And maybe I can put the speed up a little bit here. Maybe it won't be quite as dumb. So, all right. You can see that his foot plants right there, but it's still sliding forward. And .5, maybe put them to 1. So that's, all right, well, let's go back to 1.5. So it's too slow. We want him to be fully walking at a lower speed. So let's try 1.25. It's not bad. That could possibly work. So let's bring this back up to normal speed. Okay, so he's walking, and let's go ahead and change his speed. Oh, he's going at 1. Let's try you at 3. Let's try him at 0.5. So I think his walking and idle animation leaves a lot to be desired, but hopefully you're not exactly spending much time with the character kind of moving at this kind of unnatural, slow, consistent pace. Let's say 4.5 is his run, and I think that looks all right.
So quick question just for understanding.
Yeah.
What you were changing in the previous screen was the threshold for the animation to start. So the speed threshold for that animation under the project settings.
Yeah.
Or
yeah, this stuff right here.
Yeah, that one.
Not exactly. So if you think about this as if it were a linear interpolation, right? You know what? Here, let's do this. I can just bring it up over here. Let's play. All right. So this is the best way to show this. All right. So at 0, he's not moving at all, right? And here's the line for just the idle state. You can see that as the speed goes faster, the idle state goes down. And as the idle ramps down, the walk ramps up, right? So the walk is already starting once you get past 0. It's just not up to being like 100% until it gets to 1.5. So if I bring this up here, that's about 1.5-ish right there, and that's his full walk. So, and then once you get there, right, we're not blending the idle animation anymore. Now it just goes between walk and run.
Okay.
All right. Cool. Well, let's see here. Okay, next up. All right. We're not going to dig too deep into the next topic, but I would like you guys to be aware of it. So all the animation that we've been doing up to this point is what we would call as forward kinematics. So the idea is that your skeleton is where it is, and then you play an animation, or you apply those joint transformations, right? And it takes you from your starting place to wherever the ending place just happens to be. Normal animation is not necessarily fully concerned about targeting something specific. It's just trying to create emotion, right? We could think about this differently and in a way that's also extremely useful for many use cases. And that's the idea is that, hey, I want to create motion, but it isn't just to create the illusion of movement. It's with a purpose. So let's say that you have a character and I want to have his hand reach out and grasp a doorknob, or I want his finger to come out and push a button, or I want to make sure that when he is walking over a pebble that his foot doesn't go through the pebble, it stands on top of it. Right? All of these use cases are the idea where we have a goal in mind. So we have to think about this generally a little bit differently. Because whenever we authored our animations, whether it was in Blender, Max, Maya, or in Unity, right? We already had those predefined. It's just a canned sequence. Whereas in the button pushing example, for instance, right? What I want to do is I know exactly where the animation should end, or more or less end, right? I know where my finger should be at some point in the animation. And so this one kind of has to work backwards, and hence the name inverse. It's saying, hey, if I know that I want to have my finger right here on the knob, and I know where I'm at right now, well, how do I work backwards to get the animation that gets me to the end goal? Right? And that's the idea of IK, or inverse kinematics. And one of the most common use cases are like for very, very practical, kind of easy use cases for inverse kinematics is kind of the like foot clamping, the making sure feet don't interpenetrate terrain example. And unfortunately, Unity doesn't make that as easy as I thought they would, and we're not going to really fully go into it, but I want to demonstrate the issue. So if I come in here and I look, now I've got, let's look at this level. All right, here's my pro builder skills right here, right? I made a giant triangle, three-dimensional triangle. And the point of this is that I wanted an incline and possibly a decline for this, my catwalk runner here to traverse so I could kind of inspect it. And we'll do, where's the camera? Oh, this is a follow script. Let's remove that. Also, I'll do the same trick here, put the camera underneath there, but I can see in the camera preview that's not the like the vantage point I want to look from. So let's start reset right here. I'm going to rotate the camera 90 degrees. Let's pull it back a little bit. That's probably fine. And let's see if we can inspect this. All right. So I think you can clearly kind of see what's already happening here, but I'll slow it down to make that easier. Well, you know, his animation wasn't authored ahead of time to know that there was going to be an angled thing right here, right? This was authored assuming the ground was going to be flat. And most of the time, you don't really want to go out and author a bunch of animations for every single use case, especially not when you can make a more simple fix. And the idea of applying inverse kinematics for the foot plant right here is to say that, well, yeah, I don't need to kind of create an animation going all the way up the body. I really just need to kind of make sure that foot gets here, and once the foot's there, I can get the knee kind of coming up here and adjust it from there. And that usually works pretty well, and most modern games at this point do this sort of thing. So let's come back here to, I think it's right here. So if you select your blend tree, you'll see this great looking checkbox right here. This wonderful checkbox that says foot IK, and be like, oh, how cool would it be if I could just check that box? And apparently the answer is that it would be too cool, because it doesn't mean, this checkbox does not mean what you think it means. By checking this box, oddly enough, all it means is that now Unity will call the magic mono behavior function for you so that you can actually write the code to do it yourself. So, you know, effectively, this is not really doing anything. It's just saying that if we defined, let's see, what is the function called? For example, let's bring up the Unity documentation. And I search for mono behavior. All right, so here's everything that's in a mono behavior. Lots of messages. Here's all the stuff that Unity will call over to your code at the appropriate time, right? You know, like awake, start, and update. Those are the ones you use all the time. But some of the less used ones would be, okay, on animator IK, right? So if you define a method inside of your class, you know, your mono behavior derivative class called onAnimatorIK, and you check this checkbox right here, then Unity would call over to your code, and you have an opportunity to do whatever you want. And that certainly isn't limited to just messing with the feet. You know, you could mess with the whole skeleton at that point, which is another reason why I think a foot IK checkbox is not fantastic. All right. Come back here. Okay. Next up, okay, well, we have a guy who can kind of move around, but he's not really interacting much, right? There's not much dynamic about it. He's kind of just doing simple movement kind of stuff. If we want to have an action kind of like, you know, raising a hand and pointing, or you know, making some sort of hand signal, right? That's not something that plays all the time. It might be something that if you're playing the game and you want to, you know, maybe give a command or something, this is an animation that maybe gives feedback to your players that, oh, yeah, you push that button, the game recognizes you push that button, and here's like a visual representation of what you just did to confirm it, right? You have that feedback. So let's come back to our demo. All right, let's see where we left off on this one. So I can right click around, just moving around, and we got a door opening. You can see that when I click around here, it's placing the target. It's actually colliding with the trigger, which is not what I want, right? So here's good, that's colliding with geometry, but this is actually colliding with the trigger volume here, right? So let's clean that up a little bit while we're here. What did I do with it? It's a door hinge, navy seal, click pather, probably this guy. Okay, so here's some code that basically, you know, it knows when I right click, it uses this handy function to get the basically just the ray from the camera to that place on the screen you clicked, right? This is just a handy shortcut for us to do that. What it's actually doing is what you see down here, where I manually do it. I'm saying, hey, here's the mouse position on the screen, here's the distance to the near plane, and now I'm doing an inverse transformation from the screen to world space, right? And that gets me a place on the screen. And then from there, you can actually make, say, hey, I want to create a ray going from the camera position, going in the direction toward that near world point, and basically does the same thing. But you know, Unity in this case gives you a handy thing where you don't have to understand any maths. You can just put in the mouse position. Here's your ray. Do a physics raycast, and you get your thing out. But the problem we had was that it was colliding with triggers, and that's not what we want. We want it to only collide with colliders that are not triggers. So let's see. I could go back to the Unity documentation. Let's try that. Oh, good, that worked. I want to do physics raycast. Physics 2D. Where's physics? Physics scene raycast? What is this? That looks like something new. Anyway, I'm guessing this probably looks just like the other one, right? There's lots of different versions we can look at here, but let's look at stuff that'll help us with triggers. And right away I can see that triggers included in that word. It's telling me about the query trigger interaction and use global. That's probably not what I want. So let's look at the query trigger interactions. That's a lot of code, but a quick scan, I can see that there's query trigger interaction ignore, which is definitely the one I want. So coming back, I could layer mask. Let's just say -1 is a way of saying all the layers. Don't worry about layers. Now I have a choice between collide, ignore, and use global. So let's go for ignore. So pop that in there, and let's go back. All right, so now that works fine. But back to what we originally wanted to do. We want to make him bring in a hand signal. And to do this now, we kind of have a little bit of a conflict. Well, let me bring in that the animation I'm thinking of. So create a new state, signal, and let's find, there's a hand signal. Okay. Hey, why did you change the name? So signal. And just to show this, actually I can just double click it, right? There we go. So here's the signal, and I'll leave it to loop right now just so that we can demonstrate some things. But let's say we want to do this and we want to do it while we're running. Well, that's maybe not quite so clear right here, right? It's like, yeah, maybe we can blend between those, but how would we do it? You know, I'm not going to come in here in locomotion and say, well, if you're going faster, let's make you do a hand signal, right? That's it doesn't really make sense to put that right there. On the other hand, if I put it right here, now it's like I have to choose between executing my hand signal versus running, and that's also not what I want. So this is where we get to use one of the things we haven't talked about just yet, and that's the idea of layers inside of our state machine. So if I come back up in here, instead of parameters, I go to layers, and hit the plus. So this is going to be, just call that the signal layer, and let's bring in the animation in here. Can I just, maybe I'll just search for it. Signal move. Okay, so good. All right, so now we've got 2 layers, and let's just see what happens. Well, he's pretty much not doing any hand signaling, right? But we can see that it's playing, and if I go back to the base layer, well, it's locomoting and it's hand signal, but I don't see a hand signal. So let's click the little gear here and see what we have. We have a weight, we have some sort of a mask, whatever that means, and we have a way to blend between this layer and the other layers. And currently that's set to override, which we're going to leave it at. And here's another one of those buttons that, as far as I know, does the same thing as what we talked about before. But let's say that instead of making this layer a weight 0, let's make it weight 1. All right, so okay, he's hand signaling now, right? But he's not moving anymore. And if I do this and say, all right, let's do half and half. All right, well, now he's hand signaling and moving, but I don't, a little bit, let me try to better control the camera here. Yeah, see, I mean, like the foot is no longer in sync because we tuned it such that the full animation was going to match that, right? But if you're only doing half of a run, well, that half of a run becomes a half-speed run, which doesn't help us too much right here. So that's definitely not how we want to do our blending. Instead, we want to make sure that things are kind of all or nothing, but we can do both at the same time. And to do that, we'd have to basically split this guy and say, all right, for this signal layer, I'm going to specifically say which bones are the valid bones like that this layer owns. And now this animation will only basically override anything that's in the previous layer for those bones that we care about, right? Like the legs can keep doing the same thing they were doing before. That doesn't really cause a problem for us. But we need a way to tell it which bones are important, right? And that's by using this mask right here. Let's come in and we can say, well, I created an example one. Let's create a new one. So I'll create animator avatar mask, right? So this will just be signal mask. And if I look at this, you know, you get something that looks like this. And here's kind of a handy Unity shortcut to doing this. You can see that, well, this mask is saying everything is okay. Well, let's say that legs are not okay, and everything else fine. That'll be okay. And then I want to tell it which skeleton I'm actually using. So we are Navy SEAL demo avatar. Import this guy, and now you can see, you know, all the bones in here if you wanted to kind of go through them. But actually, do I need to do this? Let's see what this does. So I come back to the layer and let's select signal mask and put the weight back up to 1. Back to the game view. Yeah. So wait. Yeah, okay, so that looks right now. So now basically the legs are being controlled by the base layer, and then the signal layer is only overriding those specific ones. So that's covers most of what I wanted for animation. I'll leave this open for questions. You guys, is there more animation stuff you guys want to see? You know, just let me know, or if you have any questions, you know, now's a good time. You know, feel free to jump in. No, nothing? Okay. If you guys think of anything, let me know. Otherwise, I think the next, let's see here. Next topic up was VR, I believe. So VR got 4 votes. So unless you guys let me know, I will plan to jump in and talk about VR on Wednesday. So I'll see you guys then.
Tomorrow we'll be grading, guys. So be ready at 1.
Sounds good.
Gentlemen.
Hey.
I know I talked to Professor Darkin this morning. I was having some additional issues in regards to, not additional, but just another issue with my tutorial lab. I was able to get 2 functions, but there's one thing that I'm trying to get done. It might be easier again to just display my screen.
Yeah, that's fine.
I've been,
oh, let me turn this.